Welcome to The Explainer. So, we hear a lot about AI messing up, hallucinating. But why does that actually happen? Well, today we're going to dig into that and uncover the secret recipe for building AI you can actually trust. And it all starts with finding something called a golden seed.
Okay, so let's just dive right in. We've got to ask a pretty basic question here. We see all this powerful AI, but how does it actually get built, right? Why can't you just, I don't know, dump the entire internet into it and call it a day?
Well, the short answer, it's because most of the data out there in the real world, it's just a total mess. The raw material that AI learns from, these massive oceans of data, they're super noisy, they're inconsistent, and frankly, they're just packed with errors. And let's be real, you can't build a genius on a foundation of garbage.
All right, so that brings us to our starting point. Before you even think about building a smart AI, you've got to deal with that messy foundation. This is the first big hurdle, the raw data problem. So, what is a raw data set? Just think of it like a gigantic, unsorted pile of ingredients, okay? Let's say you scrape 100,000 animal photos off the internet because you want to teach an AI to recognize cats. Well, in that huge pile, you're going to have photos of cats, sure, but also dogs, tons of blurry pictures, and images that are labeled cat but are actually like a picture of a pigeon. It's massive, but it's a total mess.
Yeah, there's a perfect analogy for this. It's like having a big bag of flour, but it's mixed with stones and dust. You've got the main ingredient, right? The flour is in there, but it's so contaminated you just can't bake a decent cake with it. It's pretty much useless as is.
And this really shows you the problem visually. You start with this huge quantity of data, which on the surface sounds amazing, but the quality, it's rock bottom. And if you try to train an AI on this stuff, well, it's just going to learn all the wrong things.
Okay, so how would we actually clean up this mess? How do you get the stones out of the flour? Well, that brings us to the very first step of refinement, sifting the data, using something called clustering.
The core idea here is pretty clever. You use algorithms to automatically group similar data points together. But here's the trick. You don't just rely on one algorithm. Nope, you use a bunch of different ones. Because each one kind of sees patterns a little differently. And the only data you keep is the stuff that every single algorithm agrees on. It's all about finding that consensus. You can think of it like this. It's like you've got a committee of different machines, and they're all voting on which data points belong together. By doing this cross-check, you filter out all that noisy, confusing data that any one algorithm might have gotten wrong. Only the data that gets a unanimous yes vote gets to move on to the next round. And look at what happens. This is the trade-off right here in front of you. That huge pile of 100,000 photos, it might shrink all the way down to just 30,000. So yeah, the quantity takes a big hit, but look at the quality. It's shot way up. We've basically sifted out the biggest rocks and junk from our flour.
All right, so our flour is sifted, it's cleaner, but is it actually good enough to bake that cake yet? To figure that out, we move to step 2, which I love to call the AI bake-off.
So here's what we do. We take that cleaner data, our core data set, and we use it to train a few different kinds of AI models. Then we test them. And the rule is simple. We only keep the data that every single model can learn from easily and recognize with, like, super high accuracy. We're talking over 90%. Stick with me on this baking analogy. This is like test baking your dough in a bunch of different ovens to see what works best, right? You train different AI models. Maybe one is an expert at seeing textures, while another one is amazing with shapes. They all have their own strengths. We only care about the data that all of them find super easy to learn from. This is how you weed out those really tricky examples that could easily trip up a single AI. And you guessed it, our pile of data shrinks yet again. We go from 30,000 images down to maybe 15,000. But look at that quality bar. The purity, the reliability of what's left, it's just off the charts now. This is the good stuff. This is the high-grade material we've been after.
Okay, we're almost there. We're at the final and, you could argue, the most important stage of this whole purification process. It's time to bring in the ultimate judge for the final polish, a real live human expert.
So this final step is a showdown. You take the data that all our AIs agreed on, and you put it up against what a human domain expert says. So in our animal photo example, you'd bring in a zoologist to look at the images. And the only data that makes it into this final elite set is the data where both the committee of AIs and the human expert are in perfect agreement. And what are we left with? A tiny, pristine data set. I mean, look at that. Maybe just 5,000 images left from our original 100,000. This is the golden seed. This is the stuff where super smart machine intelligence and subtle human expertise see eye to eye. It's about as close to ground truth as you can possibly get. So let's just quickly run through that journey one more time. We started with the raw data set. That's our flower full of stones. Then we sifted it, getting us the core data set. After that, we did our test bake with multiple AIs to get the core of core data set. And finally, the human expert check gave us the golden data set, our perfect golden recipe.
Okay, awesome. We've got our super precious golden data. But here's the thing. Its real power isn't just in having it, it's in how you use it, not as a one-off, but as part of a living, breathing system.
You have to be strategic about this. You start by training your AI on that small, perfect golden data set. That teaches it the absolute core, unmistakable patterns of what it's trying to learn. Then, you carefully add in the slightly larger core of core set to build on that foundation. And finally, you supplement with the even bigger core set to really broaden its knowledge, all while keeping that quality control front and center. And this is maybe the biggest takeaway of the whole thing. This is not a one-and-done task. It's a living, recursive process. The world changes, right? New data is always coming in. So you can run this whole system again and again, and it just keeps getting better, constantly refining its picture of reality. And the benefits here are just huge. I mean, because you can keep running this filtering process, you can constantly improve your data. You could even start to get super specific, like instead of just a cat category, you could eventually have enough good data to split that into Persian cats and Siamese cats. It even creates a feedback loop that helps you double-check how reliable your human labelers are. It's a system that just gets smarter and smarter at every single level.
So, all of this leaves us with one last really big question. It kind of takes us out of the purely technical and into something, well, a bit more philosophical. In this whole quest for ground truth, what happens when you have a disagreement? When your committee of super advanced AIs looks at something and says it's A, but your seasoned human expert looks at the very same thing and says, no, it's B. Who gets the final say?